Hi, this week's lesson is about types of triangles, and really we're going to be talking about the properties of triangles. Before we get into the meat of the material, just a quick reminder about triangles. They have three sides. They are a type of polygon. So it's an enclosed two-dimensional figure with straight sides, and it happens to have three, which goes with our prefix tri, tri. The interior angles, meaning the inside of the shape, will always add up to 180 degrees. So if you measure all three angles here on my triangle, you will add them and the number will always be 180. How many degrees are in a triangle? Is it A, 90 degrees, B, 180 degrees, C, 275 degrees, or D, 360 degrees? So when we talk about types of triangles, it's important to know that there are two ways that we classify them. The first one is by the length of the sides, and we get these three names: equilateral, isosceles, and scalene. Then the second way that we can classify them is through their angle measurements: acute, right, and obtuse. Now, I have these numbered 1 and 2, and that's not that important. You can do the length first, or you can do the angle first. It doesn't matter. However, when you classify the triangle, you have to be able to pick which kind of side does it have and which kind of angle does it have. So it has two names for every single triangle. But first, we're going to discuss each type separately. What are the two ways we classify triangles? Is it A, color and shape, B, name and height, C, area and perimeter, or D, angles and side length? So let's talk about when we measure by their angles. You can see here we have acute, right, and obtuse. This should sound familiar because we just had a lesson on the types of angles recently, and these are our three most commonly used types of angles. So if I look at an acute triangle, it must have three acute angles. And you can see those three acute angles labeled here in the triangle. Each of those angles is less than 90 degrees, and it has to be all of them. It can't just be one acute angle. In this case, you have to have each point of the triangle be acute in order to fall in that category. And you'll see why in a moment. The next one we're going to look at is the right triangle. It has one right angle, meaning that that right angle must be 90 degrees. And we see our square indicator, which we know from our lesson last time was the giveaway for 90 degrees. Now, if you remember our rule about the angles always equaling 180, if we already have one that's 90, we know these both have to be acute because they're going to have to be numbers that add up to 90, right? If I know that it's going to be 180 altogether, this is already half of the total measurement of the angles. So these would both have to be acute. That's why I can't just look for one acute angle when I'm talking about my first type, the acute triangle. That's why this has to be all three acute. Hopefully that makes more sense now. Then my last type, when I talk about angles, is an obtuse triangle. And you can see here our obtuse angle is labeled. And this is a wider open angle. You can only have one obtuse angle in a triangle, and it has to be more than 90 degrees. It cannot be 180 degrees because that would be a straight line. What do we call a triangle that has a 90-degree angle? Is it A, right triangle, B, isosceles triangle, C, acute triangle, or D, scalene triangle? So next we're going to talk about the triangles that are measured by the length of the side. So now we're only looking at the measurement of the length, okay? We don't have to worry about what kind of angle at this point. We're just going to look at the sides. So my first type that I'm going to discuss is an equilateral triangle. And we can look at the word equilateral and notice that it starts with the prefix equa, just like equal. That's because all the sides are the same. So if this was 2 feet, then this would be 2 feet, then this would be 2 feet. They would all have the same measurement. Another thing that you may not know yet is that equilateral triangles also have equal angles. So if you ever have an equilateral triangle, this is a giveaway that the angles will all be 60 degrees. 60 plus 60 plus 60 equals 180. Next, we're going to talk about the isosceles triangle. This one has 2 sides that are equal. And you can see here my hash marks are showing me that this side is equal to this side. But then down here, this side, the bottom or the base, has 2 hash marks in it, whereas my left and my right each have 1 hash mark. That means that this measurement is equal to where there's the same number of hash marks. The base has 2 hash marks or 2 little lines going through, which means it's a different measurement. So an isosceles triangle has 2 equal sides, and it has 2 acute angles that are equal. Last, I have my scalene triangle. In the scalene triangle, there are no equal sides. So you see I have 1 hash mark on the left, 2 hash marks on the base, and 3 hash marks on the right. That's because each of these sides is a different measurement. If you were to get out your ruler and measure them, none of them would be the same. And on a scalene triangle, none of the angles are the same either. So even though we're really just looking at the side measurements, sometimes the angles will matter to help us figure out what the sides are. What do we call a triangle that has no equal sides? Is it A, equilateral triangle, B, acute triangle, C, obtuse triangle, or D, scalene triangle? So here's a review slide, and first we start out just looking at angles. So here you have an acute angle, and we see that it's got that narrow point. This is less than 90 degrees. Now, if I continue down here, I can see this is triangle DEF or EFD, whatever, this triangle that we're looking at here. Each of my 3 angles is less than 90 degrees. Please note that if you look at them, they do not appear to have the same measurement. Just because it's an acute triangle doesn't mean they're going to be the same. Next, I move over to my right angle. And we know the square measurement means, oh, that's 90 degrees. It has to be exactly 90. So when I look at my right triangle, I see, okay, there's that square, 90 degrees. That's my dead giveaway. There's a right angle. It's a right triangle. And then my other 2 angles are acute. Then I have my obtuse angle. Remember we called it that wide open angle? It has to be greater than 90 degrees. And then when I look at a triangle that uses that same type of angle, an obtuse triangle has 1 obtuse angle and then 2 acute angles. So you always want to look for the obtuse one first. If you see a triangle and you're trying to use process of elimination, I would always start to look for the right angle first because the square is going to be the easiest thing to find. If you see a triangle that has a square, you're done. Automatically, you know it's a right triangle. If it doesn't, if it were me, my next thing to look for, I would look for an obtuse angle because I would say, okay, there's maybe no right angle, but if it had an obtuse angle, I would say, okay, well, I'm done because there can only be 1 obtuse angle and that would be the name. I would not automatically start to look for an acute triangle because look, there's an acute angle here, there's an acute angle here. There's an acute angle here, there's an acute angle here. So if I was in a rush and I saw this obtuse triangle and I said to myself, okay, well, look, there's an acute angle. Oh, it must be an acute triangle. I'd be wrong because this obtuse angle changes the answer. So if you're trying to identify a triangle, first look for a 90, then look for an obtuse. If you don't see either of those, then start to ask yourself, are all of my angles acute? Let's look at this bottom row here. We are given the side measurements. So on this one, you see each side is 5 units. We don't know what the units are. They're feet, centimeters, miles, who knows? So 5 units, they're all the same length. Equal means equilateral. Next, I have isosceles, and you can see the 6, and the 10. 2 of the sides are the same length. Then, if I look at my third one, I see 7, 5, and 9. None of these are the same. So in a scalene, no sides are the same. Now, we talked about earlier, when we name the triangles, really, we should name them with 2 names at once. So I'm going to look at this triangle in the middle here. And first, I'm going to say to myself, okay, what kind of angles should I be looking for? So remember when I said earlier, if I'm using process of elimination, first thing I'm going to ask myself is there a right angle? And look at that. There is. So guess what? I automatically know it's a right angle. And there was supposed to be something. There we go. So we know that's the right angle. That's my answer for that one. So now I need to think about my sides. I have 5.3, I have 3, and I have 6. None of those are the same. So it can't be equilateral. That means they're all the same. Isosceles means 2 are the same. So it has to be scalene. None of them are the same. So I would name this a right scalene triangle. That's how you come up with 2 names for one triangle. Figure out the angles, figure out the sides. It doesn't really matter which order you go in. Some people prefer the angle first, but you could be correct either way. Can an equilateral triangle also be obtuse? So think about what I was talking about a moment ago. Equilateral means all the sides are the same. Take a look at your angles. Could this be an obtuse triangle? A, yes. B, no. What kind of triangle is this? So again, let's look at the sides and let's look at the angles. If I look at the angles first, I'm asking myself, do I have any right angles? If you see a right angle, then you're automatically done. If not, keep going and ask yourself, do I see an obtuse angle? If you see an obtuse angle, good. If you don't, keep going and say, are all of my angles acute? If they are, that's the kind. So you have to ask yourself, did you find a right angle? Did you find an obtuse angle? Or are they all acute? That's half of the name. Then for your second half of the name, you have to say to yourself, okay, look at my side measurements. Are they all the same? Are 2 the same? Or are none the same? So now, look at our choices. Is it an acute right triangle? Is it an obtuse scalene triangle? Is it an acute isosceles triangle? Or is it a right isosceles triangle? This has no equal sides, so it's scalene. If I look for my angles, this is, by the way, we're looking right here. This is the same thing we just looked at. So if I look at my angles, first I look for a right angle. Well, if I wanted to find a right angle, I could say to myself, okay, I would have to go vertical, and clearly that did not match. So we know that wasn't the right answer. And now if I think about this same angle, it's pretty wide open, so that makes it obtuse. So this would be an obtuse scalene triangle. Let's try again. What kind of triangle is this? Look at your angles. Do you have a right angle? Do you have an obtuse angle? Or are they all acute? Now think about the sides. Are they all the same? Are 2 the same? Or are they all different? So is it A, acute, equilateral? Is it B, right, equilateral? Is it C, right, isosceles? Or is it D, obtuse, right? This is the same triangle that we just saw in the question. So if I'm following my steps, I ask myself, is there a right angle? Well, look at that. There certainly is. Good. So I know, okay, half the name is right. And when I think about my sides, I'm saying, okay, are they all the same? Well, these two are, and then this one looks way longer. If I wasn't sure, I could use a ruler. And I could say, all right, let me take this ruler over here and measure, line up my 0, align my measuring line a little bit better, and I can see it's about 8.5, give or take. So 6, 6, and then 8.5, not all the same, only 2. So that makes it a right isosceles triangle. Now, I want you to list one fact you learned from today's lesson. After that, you're all done. Have a great day.